Hello there. You're very welcome to the physics lecture series by your own personal physics tutor, Dr. Rima McMullen. In this lecture, we are going to continue to work on problems of dimensional analysis. These problems have been asked in previous years' JEE exams. Now you will see that these problems are very instructive and are useful not only for the students who are preparing for JEE, but also for students who are preparing for NEET exam. In fact, these problems are useful for any student who is preparing for any kind of exam of physics or who is just studying physics. So before I start today's lecture, just like I tell you every single time, you will never learn physics by watching other people do it. In order to learn physics and to gain the insight and the confidence that you need to be successful in physics, what you need to do is you need to solve problems on your own. So for that, what you should do is after you have understood the problem statement, pause this video and solve this problem on your own on a piece of paper. And after you have solved it, come back and check your solution. Now, if for whatever reason you're not able to tackle the problem on your own, despite trying it, despite struggling with it, then it's okay to watch the solution, but then you have to pause the video and do the solution again on a piece of paper. Only then you will learn it. Okay? So I strongly recommend, I strongly urge that you solve these problems with your own hands on a piece of paper. Okay? Alrighty. Let's move on to problem number 1. Problem number 1 says that we are given the following equation. Consider the following equation, which is E equals B minus X squared divided by AT, where E is energy. Okay, this is energy over here. X is length. Here's X up here. In the numerator, it is length. And the time in the denominator, T in the denominator is time. So usual symbols for energy, length, and time. What are we asked? We are asked to find the dimensions of the product AB. Now you'll see that A is down here in the denominator and B is up here in the numerator. Okay, all right, so how would we do it? So on the left-hand side, so our goal, let's write down our goal here. If we know the dimensional formula for AB, then we know the dimensions of AB. We know that in this problem, on the left-hand side is energy, and the dimensional formula for energy is M1 L2 T minus 2. This is my left-hand side. This is energy, okay? Now on the right-hand side, I have the numerator. The numerator on the right-hand side. It is B minus X squared. Now B minus X squared, what is it? It is an expression. This is an expression. So what's the difference between an expression and an equation? An equation will have an equal sign, while an expression doesn't have an equal sign. So B minus X squared, this is an expression, while E equals B minus X squared over AT, that was an equation. I hope that now you have understood the difference between equation and an expression. So in this expression, we're going to use certain kind of principle that I have talked about quite a bit in the previous lectures. Do you remember what's that? We have talked about only one kind of principle. Principle of, tell me. Principle of homogeneity. What does it say? It says in an equation or an expression, every single term in the equation or the expression will have exactly same dimensions. Now, we're given here B minus X squared, this expression. How many terms are in this expression? The terms are separated by either a plus or a minus sign. So here B and X squared, these are separated by a minus sign. So there are two terms. B is one term. So here's one term, B, and X squared is the other term. And the principle of homogeneity says whatever are the dimensions of one term are the dimensions of the other term, and so on. So we know that in this expression, X squared, it has dimensions of length squared. right? This is your x squared. Or if you wanted, you could have said just x equals, dimensional formula for x is m0 L1 T0. But now I want x squared, so this is squared. You write square outside the parentheses, and then you bring the square inside, and it multiplies each of the powers inside, which gives you this equation over here, this dimensional formula. So if the dimensional formula for x squared is m0 L2 T0, that means the dimensional formula for b is the same, right? That is the principle of homogeneity. So there we got the dimensional formula for b. Coming back to our problem, the equation is E equals b minus x squared divided by at. Will be dimensional formula for E equals dimensional formula of everything on the right hand side. Now the right hand side, I will write this as b minus x squared over at, the dimensional formula of b minus x squared divided by dimensional formula of at, equals b minus x squared is dimensional formula. Now this is an expression. This entire thing will have just one dimensional formula. Unlike at the bottom where I have two factors that are multiplying. Now I will have dimensional formula of each of these multiply. So this is one very big difference. If you have an expression, you will take the dimensional formula for the whole expression. However, if you have some factors like a and t multiplying or dividing, then you will take the dimensional formula of each of those factors individually and multiply them together, like I'm doing here at the bottom, okay? Now, coming back here, just writing this out again. Now, what do we know here? I do know the dimensional formula for E. I know it. I know this dimensional formula as well for b minus x squared. And I do know the dimensional formula for just t. What am I trying to find? Dimensional formula for a. So that means I want to isolate a. For that, let's go ahead and multiply both sides of the equation by a. This way, I'm getting rid of a on the right-hand side. But like I said, I'm trying to isolate the dimensional formula for a. However, on the left side, you see that I have dimensional formula for a times the dimensional formula for E, the energy. So to isolate a, what you will do is divide both sides by the dimensional formula for E. Okay, so what does this give me? These E's cancel out. On the left-hand side, I get dimensional formula for A equals b minus x squared's dimensional formula divided by dimensional formula for T times the dimensional formula for E. Are you with me so far? Okay. If you have any questions, if there's anything that doesn't make sense, let me know in the comments. That's the only way I will get to know that. And if there's anything I could improve, I could do better, let me know that as well, please. I'll try my best to incorporate your suggestions. B minus x squared dimensional formula m0 L2 T0 divided by dimensional formula for T m0 L0 T1. Dimensional formula for E, the energy, m1 L2 T minus 2. Very good. Now, what I'm going to do is, okay, there's more than one way to do it, right? Let me show you long way, but it's more illustrative. M0 L2 T0. This is already at the top, correct? Then from the bottom, this, I'm going to bring it upstairs here. This will be M0 L0 T1, and this will be raised to the power negative 1. Okay, very good. Next, I'm going to bring the second factor at the bottom, second dimensional formula at the bottom upstairs. And this will become m1 L2 T minus 2 to the power minus 1. What does this give me? The first dimensional formula stays the same, m0 L2 T0 times m0 L0. Now this minus 1 is coming inside and multiplying each of the exponents. So zeros multiplied with anything still remains 0. Hence m0 L0. However, t becomes t to the power minus 1. Same thing I'm going to do with the Last factor now. -1 comes inside and multiplies each of these exponents inside. It gives you m to the -1, l to the -2, t to the +2. Two negatives cancel out. And of course, on the left-hand side, I have a here. Now I get this m0 times m0 times m to the -1. What does that give you? M to the power 0 plus 0 minus 1. Basic rules of algebra, nothing fancy here. L squared times L to the power 0 times L to the power -2. Last, T to the power 0 minus 1 plus 2. Okay. What do I get? On the right-hand side, I have m to the power -1, L to the power 0, T to the power 1. This is my A. Now, I already know B, and I'm asked to find out the dimensions of AB. This is the question's dimensions of AB. So let's go ahead and find out the dimensional formula for AB, because this is basically AB's dimensional formula. This is my B here. A is m is to the -1, L0, T1. And what is B? B is equal to m0, L2, and T0. This gives me now m to the power, here, multiply these two, -1 plus 0. L to the power 0 plus 2. This is 2, here's 0. 2. T to the power 1 plus 0. M to the power -1, T to the power 2. Sorry. This is L here. L to the power 2, T to the power 1. So the dimensions of AB equals -1, 2, plus 1. This is your final answer. Here you go. Got it? This was our entire solution here. It fits right here, okay? So what I did was, I was given an equation, E equals B minus x squared over AT. And I'm told that E is energy, x is length, and t is time. And my problem is that I want to find out the dimensions of the product AB. So I need to find the dimensions of A and dimensions of B. In other words, dimensional formula for A and dimensional formula for B, and multiply them out together. Okay? To do that, first I use the principle of homogeneity to find the dimensional formula for B. And next what I did was, after I found the dimensional formula for B, I used the equation E equals B minus x squared over AT, and substituted the dimensional formula for everything here, which is E. B minus x squared has one dimensional formula and dimensional formula of t at the bottom. And I solved for dimensional formula of A. Well, once I have A's dimensional formula, after that, it couldn't be any simpler really, right? So my answer is -1, 2, 1. Any questions? Let me know in the comments. Moving on to problem number 2 next. Problem number 2. Problem number 2. Let mass m be represented by the following equation. I'm going to rewrite the equation. K times c to the power p. K is dimensionless constant. C is speed of light. The problem statement doesn't say, but anytime you see lowercase c in physics, it stands for speed of light. Times g, uppercase G to the power -1/2. Uppercase G is universal gravitational constant, times h, lowercase h to the power 1/2. Lowercase h is Planck's constant. Okay, so we want to find what value of p satisfies the above equation for m. Okay, now you will see that uppercase G, universal gravitational constant, and Planck's constant are used so many times in these problems of dimensional analysis that it's a wise idea to memorize the dimensions of G and of H. So know how to do things, know how to solve for things, but also, if possible, especially at your age, you should be able to memorize things. Very quickly, let's see how we can find the dimensions of uppercase G and of H. So Newton's law of gravity says that the force of gravity between two masses, m1 and m2, equals uppercase G, the universal gravitational constant, times the product of the masses divided by the square of the distance between the two masses. Now we'll look at this equation in very detail when we learn Newton's law of gravity. Okay? For now, I am interested only in this G. So let me rewrite this equation in terms of G. Hopefully you can do this much of math. So G is FR squared over M1 over M2. Now I want to get the dimensions of G. For that, I hope you remember the dimensions of F. If not, you can write down the units and break down the units into the most fundamental units of mass, length, and time. And from there, you could figure out the dimensions of G. Let me show you both ways. Let's write down the dimensions of, or the dimensional formula for F. Let me write it here. Dimensional formula of G equals dimensional formula for F times dimensional formula for R squared divided by dimensional formula for M1 divided by dimensional formula for M2. Now the force is mass times acceleration. This is Newton's second law. Now it turns out that here I have m at the top, m at the bottom. I mean, you could write this as like this. The dimensions of m1, m2, any mn is same as m. It's just m to the power 1. This is m1 L0 T0. That's all it is. So if we understand that, we can right away cancel out this m with one of the m's at the bottom. Why? Because this is dimensional formulae. So the dimensional formula for each mass is the same, which is this here. So based on that, I can do this cancellation that I just showed you. Okay. After that, I'm left with, for A, it is m0 L1 T minus 2. R squared m0 L squared T0. Okay. Divided by m, choose m1 L0 T0. This gives me m to, now I showed it to you in the last example, so hopefully you know what I'm doing here. If you can't figure out what I'm doing here, let me know in the comments. Okay. So this is the dimensional formula for G. Let me write this down here, okay? So I'm going to need this so many times. It is -1, 3, -2. Cool. Then for H. Now, as far as H goes, if you could remember one little thing, that the energy of a photon is equal to E times H. E equals H times the frequency of the photon. So from here, you can write H equals E over F. Now the dimensional formula for E is m1 L2 T minus 2. And frequency, it is 1 over time period. So, okay, let me show this to you here. Frequency is 1 over time period. So instead of this over here, I could write T at the top. So that gives me m0 L0 T1. Very well. And that gives me the dimensional formula for H is equal to m to the power 1 plus 0, L to the power 2 plus 0, T to the power -2 plus 1. That gives me dimensional formula for h to be m to the power 1, l to the power 2, t to the power minus 1. So 1, 2, minus 1. Okay, let's write this down. 1, 2, minus 1. Very good. Coming back to the equation here. What will I do here? I'm going to write down the dimensions or the dimensional formula of each of these factors. M on the left hand side, C, G, and H on the right hand side. Let's see what do we get. So M on the left hand side gives me M1, L0, T0. K is dimensionless, so I don't need to worry about this. C is M0, L1, T minus 1. It's speed to the power P. Then I have, let me use a different color here. G we said is, okay, M, L, T. It is minus 1, 3, minus 2. Well, this minus 1 looks pretty bad. Okay. And last, I have H. H is M, L, T, minus 1, 2, 1. This is to the power 1 half. And this over here was to the power minus 1 half. Okay. All right, so what does this give us? M0, L1, T. Okay, let me do something here. We're going to bring this p inside the parentheses. So this p will multiply each of the exponents. So m to the power 0 times p is 0. L to the power 1 times p is p. T to the power minus 1 times p is minus p. Here we go. Next. Now I'm going to bring this minus 1 half inside the parentheses. What does that give me? M to the power minus 1 times minus 1 half gives me 1 half. L to the power 3 times minus 1 half gives me minus 3 halves. T to the power minus 2 times minus 1 half gives me just 1. Next, do the same thing. Bring this 1 half inside the parentheses, and this 1 half is going to multiply each of the exponents. So m to the power 1 times 1 half is 1 half. L to the power 2 times 1 half is 1. T to the power minus 1 times 1 half is minus 1 half. Okay. Next, I'm going to combine the terms of these factors of m. So m to the power 0 plus 1 half plus 1 half. Okay. Then I have L to the power p minus 3 half plus 1. Then we have t to the power minus p plus 1 minus 1 half. Parentheses closed. What does that give me? I get m to the power 1, L to the power p minus 1 half, t to the power minus p plus 1 half. Parentheses closed. M1, L0, T0. Now this M1 equals this M1. L to the 0 on the left hand side equals L to the power p minus 1 half on the right hand side. T to the power on the left side equals t to the power minus p plus 1 half on the right hand side. So whenever the base is same, that implies the power is same. For this equation, base is m and the powers are also 1. Nothing to do there. For the next one, the equation in L, we get 0 equals p minus 1 half. And for the last one, you get this 0 equals minus p plus 1 half. Well, they both give you p equals 1 half. And that's what you were asked to solve for p. And this p is equal to 1 half. That means this is equal to k times ch over g all under the square root. This is your equation for m. So there it is done. Any questions, concerns, suggestions? Once again, Let me know in the comment section. Moving on to problem number 3. Problem number 3. Let the frequency of an oscillating liquid drop depend upon the radius r of the liquid drop, density sigma, and the surface tension S of the liquid as represented by the following equation. Here's my equation. Determine the value of the exponents alpha, beta, and gamma. Alright, so in this equation, remove this symbol of proportionality and replace it by constant k. This constant k it's a dimensionless constant. Now F equals k times r to the power alpha, sigma to the power beta, and surface tension to the power gamma. Now we are to determine the values of alpha, beta, and gamma. On the left hand side, I have frequency. Now frequency is 1 over time period. Rewriting the equation. So on the left hand side, if I write down the dimensional formula, I would get t to the power minus 1 here equals k, dimensional formula for r to the power alpha, times dimensional formula of sigma, the density to the power beta, times S, which is the surface tension to the power gamma. Okay, now this gives me on the left hand side m0, L0, t to the power minus 1. K on the right hand side is dimensionless. Okay, so I do not need to write m0, L0, t0, but that's what you would write if you were to. It doesn't give us anything meaningful, so let's just forget about it. This r, its length, so it will be m0, L1, t0 to the power alpha. Okay, then I have this sigma, which is density. Now density is going to be, I'm going to write down its formula for now, mass divided by volume. And the volume has dimensions of length to the power 3, length cubed. Those are the dimensions of the volume, L cubed to the power beta. And the surface tension, it is basically force divided by length. It will have the same units as the force divided by length. It's not exactly force divided by length when you define it, but the dimensions are force divided by length. So that's why I'm writing this here, to the power gamma. Okay, this will give me, now bringing this alpha inside, m to the power 0, L to the power alpha, t to the power 0. And over here I will get m to the power beta, L cubed comes upstairs, becomes L to the power minus 3 times beta gives you minus 3 beta. And there is no factor of t there. So t is to the power 0. And for force, we know that force is m1, L1, t minus 2. And this will be divided by L from here. This is to the power gamma, and this is to the power gamma. So what this gives me is that this L, this is basically to the power 1, cancels out L at the top. What do I get? I get equals M0, L alpha, T0. And then I have M beta, L minus 3 beta, T0. And last I have M, bring its gamma inside. 1 times gamma is gamma. L0, T is minus 2 times gamma is minus 2 gamma. Now let's combine all the factors of this M here. M to the power 0 plus beta plus gamma. Then I have L to the power alpha minus 3 beta, and here is plus 0. We don't need to write 0, but just to show it to you, I'm writing it. T to the power 0 plus 0 minus 2 gamma. Parentheses closed. M0, L0, T minus 1. What does this give me? Now, what I'm going to do is, here's m to the power 0, and here's m to the power beta plus gamma. Equate them. M0 equals m to the power beta plus gamma. Then I have this L to the power 0 equals L to the power alpha minus 3 beta. And lastly, I have, what do I have? T, okay, to take T to the power minus 1 equals T to the power minus 2 gamma. Now, when the base is same, you equate the exponents. So here you get 0 equals beta plus gamma. This gives you 0 equals alpha minus 3 beta. And last one gives you minus 1 equals minus 2 gamma. So we need to solve for alpha, beta, gamma, all three of them. So first I'm going to use this one here. Multiply both sides, divide both sides by minus 2. That will give you gamma equals 1/2. Once I know gamma, I can plug that in here. I have 0 equals beta plus gamma. So I get 0 equals beta plus 1/2. This will give me beta equals minus 1/2. Then last I have this equation, alpha minus 3 beta equals 0. Alpha I do not know. Beta is minus 1/2 equals 0. That gives me alpha equals minus 3/2. So I get alpha equals minus 3/2 beta and gamma. What do I have? Beta equals minus 1/2 and gamma is equal to 1/2. So here are my alpha, beta, and gamma. That's what I was asked to solve for. Now this will probably be presented as a multiple choice question to you with different values of alpha, beta, and gamma given. But this is the set that is the correct set of answer. So there you go. That was problem number 3. Did it make sense? I hope it did. Moving on to problem number 4. Problem number 4. What are the dimensions of the quantity expressed by the following expression? The expression is given here in green color. Square root of h times c to the power 5 divided by g, where h, g, and c have their usual meanings. H is the Planck's constant, g is the universal gravitational constant, and c is the speed of light. Problem number 4. What are the dimensions of the quantity expressed by the following expression, which is square root of h times c to the power 5 over g, where h, g, and c have their usual meanings, which is h is the Planck's constant, g is the universal gravitational constant, and c is the speed of light. Now, I have seen this kind of question asked in different ways. Instead of giving the expression to be h times c to the power 5 over g, they will just swap the top and the bottom and write it like this. Or they would make the power of c to be 3. I have seen this as well. And you may have seen some other variations of this. If you have, please let me know in the comment section. So to solve this problem, again, this could be done in one of the two ways. You could have used units, or you could have used the dimensional analysis. So what I'm going to do is I'm going to use the method of units here. Okay. What I'm going to do is I'm writing down this expression h times c to the power 5 over g under the square root. The units of each of these quantities is h is newtons, not newtons. It is joules. H is, let me write this again, h times c to the power 5 over g. Okay. So now we'll color code it to keep track of what I'm writing. This is equal to, writing in terms of units. Units of h is joules times seconds. C to the power 5. C is speed. Speed is always meters to the power 5 over seconds to the power 5. Very good. Divided by G. G is, okay, newtons meter square per kilogram squared. Put it under the square root symbol. Now joules. Joules can be written as newtons times meters times the seconds times meter to the power 5 over seconds to the power 5 divided by, in newtons, nope, not white, I need green. At the bottom, I'll have newtons times meter squared. And per kilogram squared, I'm going to bring this upstairs and it becomes a positive power of 2 under the square root. Moving on. Now you'll see that there are some cancellations here. Newton cancels Newton. Then I have this meter square at the bottom. Right? You see this meter square at the bottom? This will cancel one of these meters and one of the meters up here. After this, I have this seconds. This seconds cancels one of the seconds at the bottom. So what am I left with? I am left with kilogram squared times this meter to the power 4 times s to the power minus 4. And let's put it under the square root symbol. Now I have, so I'm going to write just one color now. Just simple algebra, right? So what does this give me? This is mass, right? Or before I even do this. So, which gives you kilograms times meters per second squared. Now look at this. Kilogram, unit of mass. Meters per second, unit of velocity, but it is squared. So, except for this factor, this is the units of, or this is the dimensional formula for. So mv squared, this has dimensions of what? Kinetic energy. So if I put 1/2 mv squared, this is kinetic energy. So this expression h times c to the power 5 over g under the square root has dimensions of energy. So for some reason, this seems to be a very favorite question of DEE people. So make sure you get this question. It's very easy to do it. Now, we did it using the units. If you wish, you could use it, the dimensional formulae. How? So, H. Its dimensional formula is MLT, and the powers are 1, 2, minus 1. And then I have this C. Its dimensional formula is M0 L1 T minus 1 to the power 5. Then I have this G. Its dimensional formula is MLT minus 1 3 minus 2. Yeah, I wrote this down on my side and I'm reading it from there. Because like I said, I don't believe in memorization, but you should. You need to. Okay, the first dimensional formula remains as is. In the second one now, this 5 comes inside the parentheses and multiplies each of the powers. Gives me M0 L5 T minus 5. Similarly, in the last dimensional formula, minus 1 comes inside and multiplies each of the powers, giving you m to the power 1, L to the power minus 3, T to the power plus 2. And all of these is raised to the power 1/2. Okay. Now what I'm going to do is, let's combine this m1 plus this m0 and this m1. Next I have L to the power 2, L to the power 5, L to the power minus 3. Last, T, not L. I already did L. T to the power minus 1, minus 5, plus 2. Then I have these square parentheses to the power 1/2. What does this give me? M to the power 2, L to the power 2 plus 5, 7, 7 minus 3, 4. T to the power minus 1 minus 5 is minus 6 plus 2 is minus 4. 1/2. Now I'm going to bring this 1/2 inside, and this is going to multiply each of the powers. giving me M1 L2 T minus 2. Now, M1 L2 T minus 2, once you have done this so many times, you will know it like the back of your hand that this is the dimensional formula for what? Energy. So H times C5 over G under the square root. This expression has the dimensions of, or it has the same dimensions as that of energy. As that of energy. Done. So now I've shown it to you in two different ways, using units and using dimensional analysis. Whatever you like to do it that way. Because this problem has appeared as multiple choice, so your approach doesn't matter as long as your answer is right. Okay. Moving on. Problem number 5. A force is represented by the following equation. F equals A times x squared plus b times square root of t, where x is distance, t is time. Find out dimensions of b squared over a. Okay. Now, we know that from the principle of homogeneity, each of the terms in an equation must have the same dimensions. That means dimensions of f, which is on the left-hand side, must be equal to dimensions of a times dimensions of x squared. This is one term here. Plus dimensions of b times dimensions of t to the power 1/2. Okay. Now the dimensional formula for f is m1 L1 t minus 2. Dimensional formula for a, I do not know. Dimensional formula for x squared is m0 L2 t0. Plus dimensional formula for b, I do not know, times dimensional formula of square root of t, m0 L0 t to the power 1/2. Now from the principle of homogeneity, left-hand side, these dimensions equals each of these, right? It equals this term's dimensions and also this term's dimensions, right? So I know the dimensions on the left-hand side. So what I'll do is this left-hand side, I'm going to individually equate it with each of the terms on the right-hand side. Why? Because by doing so, I can solve for the dimensional formula for A from the first term here, which is the underlined by yellow, and the dimensional formula for B, which is underlined by green line on the right-hand side. So let's go ahead and do that. That is, I'm saying M1 L1 T minus 2 on the left-hand side equals dimensional formula for A times dimensional formula M0 L2 T0. What do I want to solve for? I want to solve for this A. So go ahead and divide both sides by what? Divide both sides by whatever is multiplying A. That way we're isolating A. What does this give me? Let's swap left and right side as well. So on the, this now gives me m to the power 1 minus 0, L to the power 1 minus 2, T to the power minus 2 minus 0. With me so far? M to the power 1, L to the power minus 1, T to the power minus 2. This is the dimensional formula for A. Now moving on to the dimensional formula for B. On the left hand side, I have M1 L1 T minus 2. On the right hand side, I have dimensional formula for B times M0 L0 T to the power 1/2. So once again, we need to isolate B. So divide both sides by whatever is multiplying B. On the right hand side, the dimensional formula M0 L0 T half cancels out. Let's go ahead and swap left hand side and right hand side. That gives me B equals M to the power 1 minus 0, L to the power 1 minus 0, T to the power minus 2 minus 1/2. That gives me M to the power 1, L to the power 1, T to the power minus 5/2. That is B. What are we asked to find? We're asked to find the dimensions of B squared over A. Okay. So B squared over A. This is how we're going to find the dimensions of b squared over a. Find the dimensional formula for b squared, right? So here. Now b is m1 L1 t to the power minus 5 halves to the power 2. And what's a? A was 1 minus 1, 2. Okay. 1 minus 1 minus 2. Just to check it. Yep. Now what does this give me? Now 2 outside the parentheses at the top goes inside and multiplies each of the powers, giving me m2 L2 t to the power minus 5 divided by m1 L minus 1 t minus 2. Okay. Now this gives me m2 minus 1 L2 plus 1 t minus 5 plus 2. Do you get this? m1 L3 t minus 3. So this is the dimensional formula of b squared over a. So dimensions of b squared over a will be 1, 3, minus 3. There you go. So that was problem number 5. And the last problem for this lecture. In the next lecture, I'm going to bring you more tedious, more complicated problems of the dimensional analysis that were asked on the advanced test of JEE. Now, students who are preparing for NEET, here's the thing. If you can solve hard problems, easy problems become easier. So I understand that on NEET, you're asked relatively simpler problems. But if you can solve these problems, the NEET problems will be like a cup of tea for you, right? So not very long from now, I'll be back with next lecture on dimensional analysis problems very soon. You keep studying. Take care. I'll see you very soon. Bye-bye until then. Have a good one.